So if the z distribution is just the normal distribution, then the value of z that we're given tells us where we sit on that normal distribution in terms of standard deviation units. Let's take a look at what I mean by that. A z of 0 means I am right at the mean, right? And so if I'm looking at a histogram or a frequency distribution of values, a z of 0 is just an indicator that I'm right at the mean. A z of 1 tells me that I am one standard deviation away from the mean. So this is z plus 1 right here, whereas z of negative 1 is I'm one standard deviation below the mean, right? The sign tells us, the plus or minus, whether I'm above the mean or below the mean. So 1 tells me I'm one standard deviation above the mean. A 2 tells me I'm two standard deviations above the mean. 3 tells me I'm three standard deviations above the mean, and vice versa for the negatives of that. So all z tells me is how many standard deviations above or below the mean I am. And a z of 0 means I'm right at the mean. We can turn this then into probabilities, right? Because we know the probabilities associated with the normal distribution, we can understand where our probabilities are related to z. So, and this goes back to that percentiles discussion. So a z of plus 2, right, a z of 2, we know that, well, about 2.5% of scores are above that, and about 97.5% of scores are below that. A z of negative 2, we know that about 97.5% of scores are above that, and about 2.5% of scores are below it. A z of 0, right at the mean, we know that 50% of scores are above it, so 50% of scores are below it, right? Because this is just a normal distribution. We're pulling the percentiles, these percentages, from the normal distribution. Now, we have tables that help us do this calculation, right? So part of the problem is I have 1, I have 2, right? And this chart is really handy, but I don't have memorized what about, 0.5 and what about 1.63? Like I don't have that memorized. And so what we do have is tables. In the back of almost every stats book, there's usually a series of tables, one of which is typically the proportions of the area under the standard normal distribution, or the probabilities related to the z curve, or the normal distribution curve. This is from Warner's Applied Statistics 1. This is Appendix A from that book. And here you can see, and this is a fairly typical setup, you have 3 columns. Right, column A is values of z, right? And in this case, it goes in hundredths of in terms of decimal places, right? So you have a z of 0, z equals 0.01, z equals 0.02, right? And this is obviously just part of the page that I've captured here. It goes on quite a bit after this. Column B tells us the distance or the percentage of responses, or the percentage of values that are between z and the median, right? And remember the normal distribution, that's the median, that's the mean, that's the mode, it's all the same thing. But this is the percentage between the value of z and the median or the mean. Column C here tells us the percentage of values above it, right? So remember, z equals 0. That means we're right at the mean. What that means is that there is no space. There are no values between us and the mean because z is equal to 0. So we're right at the mean. And if you remember, the mean is equal to the median. So 50% are above the mean, 50% are below the mean. That's what we see here is a z of 0, 50% then are above that. But let's look at z equals 0.05. So if a z of 0.05, what that tells me is about 2%, 1.99%, about 2% of responses are between a 0 equals 0.05 and the mean. On the other hand, I know that about 48%, just over 48% of responses are above z equals 0.05. Now, if I add these together, I can see that if I want to know how many responses are below a z equals 0.5, what I can see is that's 48. Actually, don't add these together. I add 48, and then I have to add in the 50% from below the mean, right? And so, so from here out. And so what I would add in for how many people are below 0.05 is 0.0199, so about 2% plus 50%, so about 52% of responses are below z equals 0.05. So Z equals 1, right? What percentage of answers are below a Z equals 1, right? Well, we can see from column B the number between Z equals 1 and Z equals 0, or the mean, right? And that's about 34%. And then we add to that the 50% that are below the mean. So altogether, 84% of responses are below Z equals 1. How many are above Z equals 1? Well, we can see right here, it's just under 16%. And then what's the percentage between the mean and the value, right? We see here it's 34%. Now, what we see here is that if this only gives us positive numbers of Z. If we use a negative values of Z, we get just the opposite, right? And so now we're looking at a Z of -1. What percentage of answers are below it, right? And so this is what we're looking at here. This is Z equals -1. We use this same chart, right? Z equals 1. This is how many responses are below Z equals -1. That's 16%, right? And about 84% are above Z equals -1. And about 34% are between a Z equals -1 and a Z equals 0, right? So this turns into probabilities when we start saying, what are the chances of having a score above Z equals 1? Well, if we know that 16% of responses are above Z equals 1, then we know that that the chances of having a score above 1, Z equals 1, is 16%, right? So that's where P comes in, right? P tells us that the probability of getting an answer above Z equals 1 is 16%. What are the chances of having a score below Z equals -1? Also about 16%, right? P here is equal to 16%, or 0.16. And the chances of having a score above 1 or below 1, right? This describes a situation where we have two tails, right? So we're looking at above 1 or below 1, right? So either in this tail or in this tail. And the chances there is 32%, right? Because I have a 16% chance of being in the higher tail and a 16% chance of being in the lower tail. So the chances of having a score outside the range of Z equals -1 to Z equals 1, this is a two-tailed question, and that's 32% chance. Now let's look at Z equals 1.96. And it seems like an odd number, but it's important because it actually comes to a nice even percentage. So Z, right, so we typically talk about Z equals 2, right? But if we're really talking about Z equals 1.96, what percentage of answers are below Z equals 1.96? Well, again, it's 50% for how many are below the mean, and then 47.5% for how many are between the mean and Z equals 1.96, which gives us a total of 97.5%. So 2.5% of responses are above Z equals 1.96. And what percentage are between the mean and the value of 47.5, right? And then the same thing with -2 or -1.96. 97.5% of answers are above Z equals -1.96, and 2.5% of responses are below Z equals -1.96, right? So this gives us our odds. The chances of having a score above Z equals 1.96 is about 2.5%. For Z greater than 1, there's a P of 0.25. For Z of -1.96, right, and this should say 1.96 and -1.96, P is equal to 0.25 again. So then we can add those together, say, what are the chances of having a score either above 1.96 or below -1.96? So in those tails out to the Z equals 1.96 point, well, it's 5%, right? And this is what's really important, because oftentimes in psychology, we use this 5% as our threshold amount. When P is less than 0.05 or less than 5%, that tells us that there's a 5% chance that we're actually in one of the tails at the Z equals 1.96 amount. And we start to say that that is just too extreme. So you'll see this Z equals 1.96 come up again and again to understand that 5% that are in those two tails on either side of Z equals 1.96 and Z equals -1.96.